Hi students, this is Mr. Yao. Today we are going to talk about 5.5a, where we will learn how to use trig functions to solve 3 problems. First, some definition. Angle of elevation and angle of depression. Angle of elevation means the angle made by the ground and your line of sight to an object above you. So let's say you are right here. This is the ground and this is when you are looking up. That angle is called angle of elevation. Next, angle of depression is the angle made by the horizon of where you stand and your line of sight. So this time you're actually standing right here. That's why this is going to be the new horizon, but you're looking down. So this angle that's formed by these two lines, which is, your line of sight is looking at an object below you. So this angle right there is going to be called the angle of depression, which kind of works the same way. Let's imagine you're here and you're looking up. This angle is the same as the theta 2. So there are several different ways to view this. Now let's have a look at some examples. Draw a diagram for each of the following problems, then write an equation to present the situation and solve. Round your answers to the nearest tenth. Example 1. A ladder should be placed at an angle of 75.5 degrees with the ground against a wall. How far up will a 10-foot ladder reach? So this is kind of still the same as the definition we just talked about. Let's say this is the ground and that's the wall. Here's the ladder, right? The angle is 75.5 is with the ground. So this is like the angle of elevation because the ladder is trying to reach somewhere above the ladder, above the ground. So 75.5 degrees right there. It is asking how far up will a 10-foot ladder reach? So 10 foot is actually right here because that's where the ladder is. But it's asking how far up will it reach on the wall. So it's actually asking for this section. Now let's use our right triangle to label. Well, we are of course assuming the wall is actually perpendicular to the ground. So let's say this is our x, and that, since it's facing the 75.5 degree, that is going to be opposite, and 10 foot is actually going to be the hypotenuse. So we are using opposite and hypotenuse. Clearly that is going to be sine. So sine 75.5 degrees is going to be the opposite over hypotenuse, so it's going to be x over 10. Multiply both sides by a 10. My x is going to be 10 times sine 75.5 degrees. Put in your calculator, that should give you 9.7, and don't forget the unit, feet. That is example 1. Next, example 2. From a boat on the lake, the angle of elevation to the top of a cliff is 13 degrees. So let's say this is the cliff, and here's a boat. Saying the angle of elevation to the top of the cliff is 13 degrees. It's not going to be quite precise. So let's say it's looking right here. This is the angle of elevation, and that is 13 degrees. If the base of the cliff is 1,366 feet from the boat, so it's saying this part is 1,366 feet. How high is the cliff? And it's asking for this section. And let's call that x. So in this case, that is facing that side, so clearly this is the opposite. And we this time don't know the hypotenuse, we actually know the adjacent. If we want to use our opposite and adjacent, we got to use tangent. So tangent 13 degrees is my x over 1,366 times 1,366 on both sides. That's going to give us x equals 1,366 times tangent 13 degrees. That, after rounding, is going to give us 315.4. Don't forget unit, foot. That is example 2. Example 3. From a hot air balloon 910 feet high, so let's say this is the ground, and I have a hot air balloon like right here. And in this case, we know this is 910 feet. The angle of depression to the ranger headquarters, so let's say this is actually the ranger headquarters right here, is saying the angle of depression. So you are actually right above here. So you're looking down, and this is the angle of depression, 64 degrees. degrees. How far is the headquarters from the air balloon? How far is it is actually asking how far from the air balloon to here, so it's actually this line right here. But you might be like, wait, but I don't have a right triangle. Clearly, I don't know everything. Well, here's the thing. If you actually draw the line eyesight and you put a line here, that works. Or you can think it as 64° and 64°. 64° and this angle right down here, they are the same angle, basically. Because these two lines are parallel, so these two are going to be the same angle. I can also look at that way. Either way. So next. 64 is facing 910. That is going to be the opposite, and I'm clearly solving for the hypotenuse. That means I need to use my sine. So sine 64 degrees is going to be my opposite, which is 910, over my hypotenuse, which is x. I'm going to multiply both sides by the x. I got x times sine 64 degrees equals 910. Afterwards, I'm going to divide both sides by sine 64 degrees. So my x is going to be 910 divided by sine 64 degrees, which is 12.5. Don't forget a unit, feet. And again, what I was saying is you could also move the 910 over to right here. This is still going to be 910, and then you solve it the same way. That works as well. That's example 3. Next, example 4. A sledding run is 400 yards long with a vertical drop of 40.2 yards. Find the angle of depression of the run. So here's the sledding run, and here's the ground. That is 400 yards long. A vertical drop, so this is a 40.2 yard. It's asking for the angle of depression, which actually is right here. But again, this line, if you're up there, the eyesight and the ground, we're going to assume they're actually parallel lines. So that means that you're actually trying to find that angle. Now, if this is the angle I'm trying to find, that is my opposite, and that is my hypotenuse. So I'm going to use sine. So let's actually call this theta. So sine theta is going to be opposite, which is 40.2 over hypotenuse, which is 400. Now, in order to find an angle, remember, whenever we need to find the angle, it's like getting into the function, we're going to use inverse. So theta is actually going to be sine inverse of 40.2 over 400. You put in your calculator, that should give you theta as 5.8 degrees. That is example 4. Next, example 5. A person is watching a boat from the top of a lighthouse. So this question is slightly more complicated, but let's have a look. So this is, let's say this is the lighthouse. And the person is watching a boat from the top of the lighthouse. The boat is approaching the lighthouse directly. When first noticed, the angle of depression is 18 degrees. So let's say the boat is actually this far away at the beginning. 18 degrees. So if I connect with the boat, this angle right here is 18 degrees, or I can say this angle right here is 18 degrees. And don't forget, the boat is actually approaching the lighthouse. When the boat stops, the angle of depression is 50 degrees. So let's say the boat actually stopped right here. This time I can draw, this person is still looking at the boat. So this is my line, but this angle is 50 degrees, or in other words, this angle is 50 degrees. The lighthouse is 200 feet tall, so this is 200 feet. How far did the boat travel from when it was first noticed until it stopped? So it's actually asking for this part. Let me actually change the color. It's actually asking how far did the boat travel. It's asking for this section. So now, here's the thing. If you want to find that section, well, that is not exactly in any right triangle, so you can't do anything. So you can't directly find that side. But here's another thing. Remember, this is the lighthouse, and this is always 90 degrees. That didn't change. And no matter which triangle you're trying to look at, you are looking at, you're still using that side. So first, the boat at first is this far away, And then afterwards, the boat is this far away. And you may have noticed the difference between the first one and the second one is basically what we're trying to find. So that means you can use this bigger triangle to find a side first. You can use this bigger triangle to find this side first, and then use the smaller triangle to find that same similar side. But no matter what, if you have the 18-degree or the 50-degree, this is always going to be the opposite side. So the 200 feet is always going to be the opposite side, no matter what. Is the opposite side. Next, let's look at the bigger triangle right here. The red triangle right here. If that is the opposite side, I'm trying to find this part, and let's call that our x1. I'm trying to find my x1. Clearly, that's the adjacent side. So I'm actually having opposite and adjacent. That means I have to use my tangent. So if I'm doing tangent 18 degrees, that is going to be 200 over x1. Now I can multiply both sides by the x1. So I got x1 times tangent 18 degrees equals 200. I'm going to divide both sides by the tangent 18 degrees. So in that case, my x sub 1 is going to be 615.5. And that's just a bigger triangle. I'm going to need to find this little portion, so I'm using now the smaller triangle right here. But there's still going to be, I'm going to call that x2. It's still going to be the opposite side, which is 200 feet, and the x2 is the adjacent. So I'm still going to use the tangent. So tangent 50 degrees is, is going to be 200 over x sub 2. So I'm going to multiply both sides by the x2. I have x2 times tangent 50 degrees equals 200. Divide both sides by tangent 50 degrees. That is going to give us x2 equals 167.8. Don't forget a unit, feet for both. But I'm trying to find the difference between these two, as in how far it traveled. So it was x1 away, it was 615.5 feet away, and now it is 167.8 feet away. Clearly, I'm just going to need to subtract them. So 615.5 minus 167.8, that is going to give us 447.7 feet. That is going to be how far the boat actually traveled. So this is a slightly more complicated question, but something you got to keep in mind is this tower height, it never changed. That is the number we are going to keep using, and also the angle is always facing, no matter what, the angle is always facing the height of a tower or a cliff or a wall, whatever. So that is the side we're going to use, and we're going to use a lot of tangent if we're trying to find the ground part. So that's example 5. Lastly, example 6. A pilot is flying at 10,000 feet and wants to bring the plane up to 20,000 feet over the next 50 miles. What should be the angle of elevation to the nearest 10th? So let's say this is the ground, and at first the plane is 10,000 feet up, and then eventually the plane wants to be 20,000 feet up. And it's saying it's going to travel that, well, it's going to change that over the next 50 miles. So from here, and here's the thing, whenever we say over the next 50 miles, we're not saying that is how far the plane actually traveled. Over the next 50 miles, typically we're talking about the ground distance. So this is the actual ground distance, which is 50 miles. But we got to change that into feet because all the other things are actually in feet. So we're saying this is the ground distance, which is actually means this is actually just 10,000. We actually need to calculate the difference so that we can form a triangle. This part would also be 10,000. And there is our right triangle. He's asking what should be his angle of elevation. So this is going to be the angle of elevation. We can't just use 50 miles because everything is actually in feet. So here's the conversion: 50 miles times 5,280. That's going to give us how much is 50 miles in feet. That is going to be 264,000. So that side is actually 264,000 feet. It's asking for theta. Clearly, this is the opposite side, and this is going to be the adjacent side. I'm going to use my tangent again. So tangent theta is going to be 10,000 over 264,000. Since we're finding the angle again, I'm going to use the inverse function. So my theta is going to be tangent inverse of 10,000 over 264,000. And that, if you type in your calculator, is going to give you 2.1, well, actually 2.2 degrees. So the plane needs to fly at an angle of 2.2 degrees. So it could actually fly from 10,000 feet to 20,000 feet over the next 50 miles. So that is example 6, and that is everything for 5.5a. Thank you.